Good evening. Dear students, in the previous videos, we have learnt that reflection of the light takes place according to two laws which are called laws of reflection. Do you remember them? Let's see. The first law states that incident ray, refracted ray, and the normal at the point of incidence all lie on the same plane. Second law, the angle of incidence is always equal to angle of reflection. In the same way, refraction of light also involve two laws of refraction. Today, we shall discuss those two laws of refraction. Consider this diagram. A ray of light is traveling from first medium, which is also known as incident medium, and the medium in which the refraction of the light takes place is called refractive medium. When light travels from a rarer medium to a denser medium, the refracted ray bends toward the normal. ये आपने पढ़ा है, you have learned it. Now, there are two laws of refraction. The first law states that incident ray refracted ray and the normal at the point of incidence all lie on the same plane. The incident ray, the refracted ray, and the normal, they all lie on the same plane. No one out of these three is out of the plane of this board. Now, angle between incident ray and the normal is called angle of incidence. In this case, the angle of incidence is I1, and the corresponding angle of refraction in the second medium is R1. So, ratio of angle of incidence to the angle of refraction, that is I1 over R1. This ratio is known as refractive index of the second medium with respect to first medium. Now you see in the second diagram, as the angle of incidence increases, the angle of refraction in the second medium also increases. And you will see that the ratio of sine of angle of incidence to the sine of angle of refraction remains the same for the given pair of media, that is, the pair of media should not change. Moreover, the color of the incident light is also constant. It does not change. So for a given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant value. Now in the third diagram, the angle of incidence in the first medium is further increased, and you see that the angle of refraction in the second medium is also increased, so that the ratio of sine of angle of incidence to the sine of angle of refraction remains constant. Now this is the second law of refraction, which is also known as Snell's law. So let us make a statement. For a given pair of media, for a given color of light, these two factors are constant. Given color of light or wavelength of the light. For a given pair of media, for a given color of light, the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. This constant is known as refractive index of the second medium with respect to first medium. It is represented by N. So what you will read it? Refractive index of the second medium with respect to first medium. Consider that the first medium is air, the second medium is glass. Then this ratio is equal to the refractive index of the glass with respect to air. Obviously, glass is the second medium, air is the first medium. This is called second law of refraction, which is also known as Snell's law of refraction. Once again, let's see the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. Constant provided that the media, pair of media does not change, the color of light, incident light is the same, then the ratio of sine of angle of incidence to the sine of angle of refraction is constant. And what does this constant call? This constant is called refractive index of the second medium with respect to first medium. So let us generalize it. Sine of angle of incidence to the sine of angle of refraction is a constant. This constant is called refractive index of the second medium with respect to first medium. If the refractive index of the second medium is determined with respect to vacuum, it is called absolute refractive index and it is denoted by N. So, If the first medium is vacuum, then the ratio of sine of angle of incident to the sine of angle of refraction would be called absolute refractive index of the second medium. That is, in this case, absolute refractive index of the glass. Now consider that the velocity of the light in the first medium be v1 and the velocity of the light in the second medium be v2. Then the refractive index of the second medium with respect to first medium is also equal to the ratio of velocity of the light in the first medium to the velocity of the light in the second medium. So, refractive index of a medium with respect to another medium is also defined as the ratio of velocity of the light in the first medium, that is v1, to the velocity of the light in the second medium. Now, consider that the absolute refractive index of the first medium be n1, absolute refractive index of the second medium be n2. Now there is an interesting relation between the velocity of the light in the vacuum to the velocity of the light in the medium. Since the velocity of the light in the vacuum is a constant value, therefore absolute refractive index of a medium is also defined as the ratio of velocity of the light in the vacuum to the velocity of the light in that medium. What is absolute refractive index? Absolute refractive index is defined as the ratio of velocity of the light in the vacuum to the velocity of the light in the medium. Now, we have two media such that their absolute refractive indices are n1 and n2. Then according to this relation, absolute refractive index of the first medium will be equal to c over v1. Why? Because the velocity of the light in the vacuum is c and velocity of the light in this medium, first medium, is v1. In the same, or v1 is equal to c over n1. You can mark it first equation, you can mark it second equation, you can mark it third equation, and this is fourth. In the same way, n2, absolute refractive index of this medium, second medium, is equal to c over v2, or v2 is equal to c over n2. Now substituting the values v1 and v2 from these equations 5 and 6, we have refractive index of the second medium with respect to first medium is equal to ratio of sine of angle of incident to the sine of angle of refraction is equal to ratio of velocity of the light in the first medium to the velocity of the light in the second medium, and it is also equal to c over n1 over c over n2, or n2 over n1. Therefore, refractive index of the second medium with respect to first medium is equal to sin I over sin R is equal to v1 over v2 is also equal to n2 over n1. That's all today's. Thank you.